Yes, ma'am, you are audible.
You're audible. Okay. Why, ma'am? Okay, seventh and which one you did, Ishan? Seventh and ninth, you said.
Yes, ma'am. Easy, ma'am, these
Mm,
are.
okay. Seventh one, write the equations for the preparation of 1-iodobutane from 1-butanol. Yeah, how would you do that?
Ma'am, red phosphorus with iodine 2. Like
Hmm.
iodine.
Hmm. Okay. Or you can go for a Finkelstein reaction. No? We can go, sorry, we can go for a Finkelstein reaction also, correct? Like you can take 1-butanol, which is this, right? You can first treat it with SOCl2 and get a Cl. Once it is done, you can treat it with sodium iodide in the presence of triacetone and you can make iodobutane. Okay.
Yes,
Instead,
ma'am.
or the second part is this only. No? The second
Yes, ma'am.
subdivision is 1-chlorobutane to 1-iodobutane. Okay. Then but-1-ene. So you have but-1-ene. Okay. Either you go for direct addition of Hi, but Hi, if you add, I minus will go to that carbon which has got less number of hydrogens, and H plus will go to that carbon which has got more. Is anti-Markovnikov known with Hi, children? Any idea?
I did that only, ma'am. Anti-Markovnikov with HI.
No, you
It's
you
not
cannot.
possible.
No, actually, anti-Markovnikov addition goes via radical mechanism, and due to kinetic factors and thermodynamic factors, the anti-Markovnikov rule works only with HBr, Ishan. Be very clear. Not even with HCl.
Okay, ma'am.
So you cannot do the anti-Markovnikov addition. So even if you provide it with a peroxide, the anti-Markovnikov addition doesn't happen. It is still the Markovnikov addition because it is free radical. Anti-Markovnikov goes via free radical, and free radicals, Hi, the energetics doesn't tally up. So this will be first giving me only 2-iodobutane. Once you have the 2-iodobutane, you can now do the Finkelstein. Also, sorry. Instead, you can go for HCl. And once you have got the chlorine, you can either treat it with HCl or HBr. Once you've got 2-chlorobutane, then you can do the replacement. But why to do that? Better to take HBr. Better to take HBr. Go for the normal addition, but that will give me in the second position. So go for the anti-Markovnikov addition. So go for peroxide, get the bromine in the first position, and then do the Finkelstein reaction. Is that okay? Is that okay?
Yes, ma'am.
So direct Hi through anti-Markovnikov doesn't happen. And add anything normally, then you try to substitute, will take it to the second position. So the only thing that can be added according to anti-Markovnikov addition to get you the functional group on the first carbon is HBr. So add HBr in peroxide and then take it through the Finkelstein reaction to your desired. Clear, children, all three of you?
Yes, ma'am.
Then 6.9. Which compound in each of the following pair will react? This ninth one did I give? Yeah.
Yes, ma'am. Every
Which one will be faster to react? Via SN2 they are saying. So is it iodo or the bromomethane? Which is that?
bromo, ma'am.
Huh? Why you're
Iodo
saying
is
bromo?
heavier, no, ma'am.
Iodo longer bond, man. Easier to
Yes,
break.
ma'am. Yes, ma'am. Yes, ma'am.
I see. Whenever the reactivity is considered, reactivity of the iodo compounds will be maximum. Ri will be most reactive than RBr, which will be more reactive than RCl, which will be more reactive than RF. This is universal, ma. Don't have any doubt about that. Because of the longer bond, it
Okay.
is easier to cleave open. Okay. and
Yes, ma'am.
uh, and now they are giving you a tertiary butyl chloride, CH3 thrice Cl. This is simply Cl, and you have got CH3Cl, and they have put a straightforward question
CH3CL.
SN2. So it should be primary. Okay, had it been SN1, then you would have gone for the tertiary. Fine.
Yes, ma'am.
Okay. Pranav, can you predict the first reactions product? Here, 14th one.
CH3, CH2, CH2I plus NaCl.
That is, you just replace it with the iodine. This is Finkelstein reaction. Okay, the next one. KOH ethanol heat. What do you think will happen? Aprameya. KOH
Yes, ma'am.
ethanol. KOH and ethanol.
Elimination.
Hello.
This will be, you're traveling, I believe, na?
Yeah.
Okay. So this is going to be elimination product. Okay, the moment you see ethanol, okay, ethanolic KOH, alcoholic KOH, and heat ensures that it is elimination. Okay, so we will go for the beta hydrogen. So this is alpha, this is beta, na? This carbon is beta. So we can take out a hydrogen, put the electron pair inside, take out the bromine. So you are going to get a 2-methyl propene. Is it okay? So in other words, you are going to get a double bond with 2 alkyl groups. Clear? Okay. Can I proceed? So look at the next one. What combination is it, Aprameya? NaOH water. Ishan?
What?
Ishan, it's all right, Aprameya, it's
Yes,
all
ma'am.
right. You just listen. Yeah. NaOH water. KOH, NaOH water, anything. What that combination will be. You are also traveling,
Elimination,
man.
ma'am.
You are
No, no,
also
no, ma'am.
traveling. There is some honking.
Background noise. Okay.
Okay. Now tell me. NaOH water.
Elimination,
Is
ma'am.
it what, man? Simple. You take, say you have got please, no, reinforce the concepts. Alcoholic KOH, alcoholic NaOH, ethanol. All these are mentioning that your OH minus is not hydrated well. Alcohol, when you provide NaOH or KOH in alcohol or ethanol, your OH minus is not well hydrated. So it is not a good nucleophile. Instead, it acts as a base. This combination is a base. What will a base do? It will either take this beta positions hydrogen or this beta positions hydrogen. And when it comes to elimination, we also know that there is Zaitsev rule going on. Correct?
Yes,
So either it is this hydrogen or this hydrogen. Any one will be gone. And if it is this hydrogen, then you are going to get a more substituted double bond. Okay. But if you see the elimination happening by removal of the last hydrogen, then it is going to be this way, Cl remove, and you will be getting the double bond on the last position. Out of the two, this will be the major. This will become the minor. So the moment you see KOH, base is there, KOH, NaOH. If you provide it with alcohol, if you have dissolved it in alcohol, it doesn't dissolve. KOH is more or less ionic. It won't dissolve well. So when it is unable to get hydrated, it starts becoming unstable and starts acting as a base. So what will a base do? It will be looking for a proton from the beta position. Clear?
Yes, ma'am.
Clear? Whereas if you are treating it with aqueous, supposing you have got an alkyl halide and you are treating it with aqueous NaOH, the NaOH completely dissolves in the water. OH minus is well hydrated, so it is not in an urgency to go and pick a proton. So it will slowly go act on the electropositive carbon to replace it. So start looking for those
The Cl,
hints.
ma'am,
Hmm.
will the Cl come out with like NaCl as NaCl or
In which case? In this third case?
the first, the first, the
Yeah,
first case,
obviously.
the
In the
major case?
in the first case, yes, NaCl. That was the driving force for the Finkelstein reaction. No, this is soluble
Yes,
in
ma'am.
acetone, and this is insoluble in acetone. And because of it being insoluble in nature only, it is actually the reaction gets pushed in the forward direction. Na?
Yes, ma'am.
Okay, the Finkelstein reaction's main objective was you take an alkyl chloride or bromide, treat it with sodium iodide, which is not so ionic, so it dissolves in dry acetone. Okay, it is soluble. Once the RCl is also not very uh, like it is not soluble in the water. Remember, the RCl is insoluble in water, right? Because of the
Yes, ma'am.
energy generated between RCl and the water is not so strong to break open the strong hydrogen bonding between water. So alkyl halides are literally insoluble. If they are insoluble in water, they should be soluble in a non-polar solvent like dry acetone. So RCl and NaI both are soluble in dry acetone. Fine. Now this ensures the reaction. As the reaction happens, you get NaCl and Ri. Now this is continuing to be soluble. This is insoluble because now this is more ionic. As it is more ionic, it starts precipitating. So Le-Chatelier principle says decrease in the soluble concentration of NaCl will push the reaction towards forward direction.
Yes, ma'am.
Okay. So yes, a byproduct will be NaCl. Okay. In the third case, what can be the product, children? So this is what? Simple substitution. Na? The moment you see water with the NaOH, no ethanol, no alcohol, then it is a nucleophilic substitution. So the Br is present on the second carbon. You will simply see CH3, CHOH, CH2, CH3. Simply the replacement. Clear?
Yes, ma'am.
Okay. Now CH3, CH2Br plus KCN in aqueous ethanol. Okay, this is again, since it is aqueous, there is more of water. Okay, so what happens? The cyanide ion created here is quite soluble. And if the anion is quite soluble, hydrated well, then it will act as a nucleophile. So it will go and replace the halide. That means you are going to get CH3, CH2, Cl. Okay. Now, at this point of time, if all three of you can acknowledge me, all three of you hearing me clearly?
Yes, ma'am.
Yes.
Okay. Aprameya?
Yes, ma'am.
Okay. See, at this point of time, I'll give you one important reaction. Okay, which will help you in many, many conversions. Look at this. Okay, this is not connected to the question there. So this is an independent discussion. You take CH3CN and let me do hydrolysis. I'm going to do hydrolysis. What do you mean by hydrolysis? I am going to break the bonds present in the starting material with the help of water. When I do so, okay, I'll just recollect one of the previous reactions that we have studied. Do you remember CH3COO CH3 when treated with NaOH aqueous in the class 11? This was called as saponification. Do you remember that?
Yes, ma'am.
What we used to do? Break down the ester in the presence of an alkali. Was called as alkaline hydrolysis. Remember? alkaline hydrolysis. So what would be the product? Basically, this is double bond O and O. See, whenever you do hydrolysis, please go and check the polarity, the bond which is going to break. This bond is going to break. The oxygen here is electronegative. The carbon is electropositive. Okay. So out of NaOH, okay, or it's aqueous. So we'll assume that NaOH is simply as a catalyst there. So water can break open as H plus and OH minus. So what would you give the O minus? What would you give? You are breaking this bond in the presence of water. That is called as hydrolysis. It is catalyzed by a base. So what would happen? Out of H plus and OH minus, which part will go and join the O minus, children?
H plus.
H plus. Okay. So I would put the hydrogen here and the OH to this carbon. Aprameya, clear?
Yes, ma'am.
And last class, I did tell you one more thing. Okay. What was that? Phenol. You were not there, Pranav. Phenol, aliphatic carboxylic acid, aromatic carboxylic acids. These, whenever you have the medium as NaOH, will never stay as COOH. They would react with the base to form the salt. RCOH plus NaOH will give RCOONA. Phenol C6H5OH will react with NaOH to form C6H5O minus Na plus. Remember? So do you think the product formed will stay like this or will it become the salt?
Salt, ma'am.
So the product is O minus Na plus. O minus Na plus. Now look at the other product. This is CH3O minus receiving what? Receiving H plus. Now, so the other product is CH3OH. Now the next question. Will this alcohol also react with sodium hydroxide to form the salt? What were the things which were converted to salt?
Phenols, and
Aliphatic and aromatic
aliphatic and
carboxylic.
aromatic carboxylic acids.
What about the aliphatic alcohols? Were they converted?
No, ma'am.
So it will stay as such. Is that clear? These are the two products. So I'm just trying to make you understand that hydrolysis means you are going to break a bond in the presence of water. Are we clear?
Yes, ma'am.
So I'm trying to do that in the cyanide or a nitrite. So when you hydrolyze, it's very, very, very important. And as soon as we go into the conversions, you will see what I'm trying to say. When you are hydrolyzing a cyanide, you are actually trying to break down the compound in the presence of water. So spot the electronegativity. Nitrogen is electronegative, carbon is electropositive. So nitrogen will receive the H plus and carbon will receive the OH. So the first product that you will be getting will be CH3C OH double bond NH. Is that okay? Is that
Yes,
okay?
ma'am.
Subsequently, there are some more bonds to break. The bond between both the bonds between carbon and nitrogen can be one by one broken. So let us do the hydrolysis once again. That means still the carbon is electropositive. That will only receive OH. And the nitrogen is electronegative. That will only receive the H. So we have added the second water molecule. Any doubt about this? Any doubt?
No, ma'am.
No. Again, once again, if you do, this bond will also break. The carbon-carbon bond is quite stable. Carbon-oxygen bond is also quite stable. Carbon-nitrogen is the longest bond, so that will break. So again, okay, before even that could happen, is there any carbon which is stable with two OH group placed on it? Is a gem diol stable?
No, ma'am.
What will happen? It will lose
Release water. Yes, ma'am.
water. So to remove the water, what we need to do? You pick the OH
Ketone.
and the H.
No, ma'am.
Yeah. you will be getting CH3, C double bond O, NH2. Aprameya, Pranav, is that fine?
Yes, ma'am.
Okay. Then again continue with the hydrolysis, H2O. So what would happen? Again, this nitrogen is electronegative and the carbon is electropositive. So again, H part will go here, OH will come there. And this time you will be getting CH3, C double bond O, OH. Nitrogen is completely detached and the nitrogen, one after the other, would receive the 3 hydrogens. So it would actually, what is the concept that I'm trying to say? The concept is that if you take a cyanide and do partial hydrolysis, you will reach the stage where you get an amide. Please make a note. If you do partial hydrolysis, you will go to amide. If you do further complete hydrolysis, it will become carboxylic acid. Clear? Is it clear, all three of you?
Yes, ma'am.
Yes, ma'am.
Now, what is the
Yes.
use of, how do we use this? We can use it in a number of ways. I'll tell you. Supposing I've got CH3Cl and I want it to become CH3COOH. Can you plan the conversion using this reaction? I have got methyl chloride and I want ethanoic acid. How will you convert methyl chloride into ethanoic acid? Can you plan? Before being this, what it should have been? It should have been a cyanide, na? And you do complete hydrolysis, correct?
Yes, ma'am.
So the question is, how will you convert methyl chloride into methyl cyanide or ethane nitride? How would you do that? Look at the fourth subdivision. Fourth subdivision. What do? You replace the cyanide, chlorine with the cyanide. How do you replace?
Nucleophilic substitution, ma'am.
Yeah. So what will be the reagent used?
SN2, ma'am. Okay.
Okay, reagent, not mechanism.
Ethanol.
Ethanol in the ethanol is enough, man.
No, ma'am. Water also,
KCN,
ma'am.
KCN, KCN and aqueous ethanol. I'm asking you to look at the subdivision number 4. See, what was the product here? CH3, CH2, CN.
Yes, ma'am.
Are you getting the point, children? Yes, Pranav. Supposing I do partial hydrolysis, what would I get? CH3, CONH2. So can I now frame question? How will you convert methyl chloride, number 1, into methyl cyanide? How will you convert methyl chloride into ethanamide? How will you convert methyl chloride into ethanoic acid? Can all these three will be answered, na? Can all these three be answered with this?
Yes, ma'am.
Yes.
Yes, ma, Aprameya?
Yes, ma'am.
Okay. So you see, when you learn organic, no, the first challenge that you will face is that you will see too many reactions to learn. And I told you, after learning a particular section, like preparation of haloalkanes, you made a chart. I hope you have made. Aprameya told me that she has completed making that. Ishan and Pranav, did you do that? I was
No,
telling
ma'am.
you a one-page study material comprising of all the preparations of halogen, that is haloalkane in one page, haloarenes in one page, properties in one page for haloalkane, and properties of haloarene in one page. it will highly be useful to you to remember the reaction. So first challenge is to remember the reactions. So understand and memorize, understand, memorize, revise, understand, memorize, revise. That is first. Second is that you will, children feel that they can answer any type of question, but they don't get enough ideas to do conversion. To do the conversion, you need to have a 360-degree view on all the reactions. Like a web, you have to start connecting. So that is what we are trying to understand here. Clear?
Yes, ma'am.
Okay. Okay. So what I'll try to do is I'll try to frame some questions from this conversion questions. Okay. As simple as if I have got, let us say a 2-bromo propane. Okay. How do I make it 2-methyl propane? Come on. And I'll
Remove
give you
the
a hint.
BR.
Enema, remove the BR. But what do you have to put? I'll give you the hint. Use Wood's reaction. Or you can
Ma'am,
use Grignard.
CH3 Br.
Or
2Na
you can.
CH3 Br. Yes, ma'am.
But there is a risk of getting another product, no, Ishan?
Yes, ma'am. So, ma'am,
Will the other
BRMG
one?
CH3. Yes, ma'am. BRMG CH3.
So if you take CH3 MgBr, what will happen? This is negatively charged, positively charged. This will act as a nucleophile. It will go and attack the methyl anion and will replace the bromine. No? So you will be getting MgBr twice.
Yes, ma'am.
And your methyl group is attached. Understood?
Ma'am, we can do alcoholic KOH, ma'am.
Alcoholic KOH will do what? Will remove the HBr, no? Alcoholic KOH will remove the HBr. What will you get by removing the HBr? If you take alcoholic KOH, this acts as a base. And what will it do? It will remove the beta hydrogen and will cause the elimination. So you get propene. Next what? I don't want this. I want 2-methyl propane. Pranav.
Okay.
Understood?
Yes, ma'am.
Okay, so I'll frame some conversion questions using this. Okay, using this lesson. We'll go back to the questions, but I'll frame some questions and please try to answer. C6H5O minus Na plus. Start seeing the ONA, C6H5ONA as O minus Na plus. Okay. With a charge, it will become more and more clear. You're reacting it with C2H5Cl. What would happen?
NaCl and C6H5 peroxide.
Is my voice breaking, children? Because Ishan's voice is breaking for me.
Your voice is not breaking.
Okay. So C6H5O, C2H5, NaCl. In fact, this is one of the reactions in the next lesson, and you call it as Williamson's synthesis of ethers. Okay, what is Williamson synthesis? To prepare the ether, you are preparing the ether here. The final product is ether. You will take one as alkyl halide. One of the reactant will be alkyl halide. The other one will be RO minus Na plus. So the O minus acts as a nucleophile and replaces the halogen. Is it okay? So this is that reaction. Okay, so the name is not at all required. Okay, now Aprameya was asking me this table. Remember, It is from that table only,
Yes, ma'am.
Pramila. Yeah, just from that table. C6H5, C6H5O minus Na plus will react with C2H5Cl. This is a nucleophile provider and the product is formed. Okay, let us quickly do these and then we go to the table. What will happen when alcohol is treated with SOCl2? It's a straightforward question. And this is the most preferred.
CH3, CH2, CH2, Cl, plus SO2
Yeah,
and plus HCl.
and HCl. And this is the most preferred way of making an halogen alkane or haloalkane because both the byproducts are gaseous in nature. Okay, both the byproducts are gaseous in nature, so they will be moving out. Okay, this is what simple HBr
Anti-Markovnikov.
peroxide anti-Markovnikov. So the Br will go to that carbon which has got
Least number of hydrogens.
that is peroxide, that is normal Markovnikov, Ishan.
Oh, sorry, ma'am. More number of
Nah.
hydrogens.
CH3, CH double bond, CH2. If you add HBr, what was the molecule anyway? Take the example of that and write. No? So the case was CH3, CH2. CH3, CH2, CH2. If you add simply HBr, positive part of the addendum goes to that carbon which has got more hydrogens. Negative part goes to that carbon which has got less hydrogens. So you'll be getting CH3, CH2, CH receives the Br and single bond CH3. This is normal HBr. But if you try to add HBr in peroxide, then we'll get CH3, CH2, CH2, CH2 and a Br. This is your normal addition. Peroxide addition. Okay, so this must be the product there. Yes, Pranav, clear?
Yes, ma'am.
Okay, the last one is CH3, CH double bond C, CH3 twice. So if you are adding simply HBr, no peroxide, then it is normal addition. HBr goes to which, H plus goes to which carbon, children?
Second carbon, ma'am. From
Second.
the right, left.
Yeah.
Yeah, that one is.
Left. And the negative, the H part, positive part of the addendum goes to that doubly bonded carbon which has got more hydrogens. And the negative part goes to that carbon which has got less hydrogen. So it will be CH3, CH, add hydrogen to it, C, CH3, CH3 and the Br. Okay, that will be the product. Clear? Now going to this table. This table is actually an underrated table but it is very, very important because halogens can be converted to a number of compounds. Okay. Through this table, we can understand that you can go to a number of compounds, maybe not an aldehyde, ketone, carboxylic acid, but a lot of compounds can be formed by the nucleophilic substitution, right? Taken here. See, what is this basically? How to interpret this table? The basic interpretation will be that you take an alkyl halide. So see up here. You take an alkyl halide. Okay. Assume that you have taken an alkyl halide. So R single bond X. Now you are reacting it with a reagent. What is the reagent? You are providing NaOH. Okay. The NaOH provides you the nucleophile. What nucleophile? It is OH minus. What will the nucleophile do? Either it will carry out the SN1 or SN2 and you will be getting ROH and the class of compound that is formed is an alcohol. This is how you need to interpret. RX is taken as the starting material. NaOH is the reagent. NaOH provides me with the OH minus as the nucleophile. The OH minus replaces the X minus to provide ROH, which is an alcohol. So look at the second one. The alkyl halide is treated with water, and water provides you the nucleophile, which is water itself. The lone pairs present on the oxygen act as the nucleophile. That is going to attack, will make the halogen leave. You will be getting RO bonded to one hydrogen, another hydrogen. So oxygen becomes positively charged, and X minus. What will the X minus do? This will cause a deprotonation and the electron pair will go back and you again get an ROH plus HX. Is that clear? So the class of compound that you are going to class of the main product is alcohol again. Is that okay?
Yes,
Okay.
ma'am.
The next one, you are just now we did this. The nucleophile. Again, I'm taking Rx and treating it with NaOR dash. Well, is it not similar to C2H5Cl being treated with C6H5O minus Na plus? The moment you see RONA, please start putting the charges and that way you will be very clear what is the nucleophile. So OR minus is the nucleophile. It approaches the electropositive alkyl group and replaces the electronegative halogen. So you get R bonded to O, which is bonded to R dash, and the byproduct will be NaX. The class of compound that we are getting is ether. NaOR dash. OR dash is the nucleophile. ROR dash is the main product, which is called as ether. Is that clear? Is
Yes,
that
ma'am.
clear? Then you have got number of options. This is your Finkelstein reaction. Isn't it? The next one is Finkelstein reaction. I minus goes and replaces the chloride or the bromide. You get Ri plus NaCl or NaBr or in simple NaX. So if you treat the Rx with NaI, it goes for halogen exchange. I minus is the nucleophile. I minus attaches itself to the alkyl group and you get alkyl iodide. Okay. The next one. This is very popular. And when we go to the last lesson, these reactions will be again and again repeated. These three. What are they? If you have Rx and you use NH3, okay, NH3, like water molecule, which was acting like a nucleophile here. Okay, when water acts as a nucleophile, the lone pair present on the oxygen is the one because of which it is able to attack. Similarly, here, ammonia, lone pair present on the nitrogen. So the attack is by the lone pair on the alkyl halide. X minus goes off. So you'll get R bonded to N, H3 positive charge. Nitrogen, whenever nitrogen is neutral when you have three hydrogens on it, when nitrogen is trivalent. The moment nitrogen gets the fourth bond, it's making the fourth bond, it acquires positive charge. X minus will left. Same way, X minus will come, take a proton and will become RNH2 plus HX. So you get a primary amine. Is that okay, children? This reaction is there in the preparation of amines. That is in the fourth lesson. Is that okay? Is it clear?
Yes, ma'am.
Okay. Okay.
Yes.
Compared to ammonia, the RNH2 is even a better electron rich group. Because in ammonia, the lone pair was responsible to act as a nucleophile. But here, the lone pair electron density is further enhanced by the electron releasing alkyl group. So it's even better in terms of having lot of electron density. So what will happen? The nitrogen with the lone pair comes and attacks. The halide leaves. So what will you get? Assume this is R dash, just to distinguish the two alkyl groups. I'll put it as R is bonded to NH2, bonded to R dash. Now, Aprameya, tell me whether there will be a positive charge on this nitrogen or not.
Um, no. Won't there be a negative? Or
No. When nitrogen is trivalent, no positive charge. Okay, lone pair is there. The moment there is a fourth bond, it would have used up that electron pair to form the bond.
oh yes, ma'am.
So nitrogen will definitely have, the moment you have 4 bonds around nitrogen, you will have a positive charge. So that means it is the duty of the X minus to take out the proton, and you will be getting R, NH, R dash and HX.
Yes, ma'am.
Okay. Now, if ammonia was electron rich and could act as a nucleophile, and RNH2 was better because of electron donating nature of R, don't you think RNHR will be even better because there are 2 lone pairs, I mean 2 electron donating groups? Isn't it a better
Yes, ma'am.
nucleophile? Yeah. So what will that do? It will again attack on Rx, and this time you will get R, N, H bonded to another R, and you will be getting a positive charge with X minus. Finally, it will settle down as R, N, R with an R. So I'll write it in short. Okay. So R, X, check this out, NH3. Okay. The first reaction is RNH2 plus HX. Is that okay? The first reaction is fine.
Yes.
This will act again as a nucleophile on Rx and will form RNHR and again an HX. The nitrogen attacks, halide leaves. That halide with one of the hydrogens will form HX. So you actually had an Rx which forms a primary amine, which in turn forms a secondary amine. Why secondary and all we will discuss later when we come to fourth lesson. This doesn't stop the process because there is a lone pair. It will attack subsequently on one more alkyl halide. The halide is lifted off and you will be getting Rn. So one after the other, the 3 hydrogens of the ammonia will get replaced by the R. Is that clear, children?
Yes, ma'am.
Yes.
And the product thus formed is said to be tertiary amine. So see here now, look at this table. So when Rx is treated with ammonia, you first get a primary amine. Okay, you first get a primary amine. This is your primary amine. When it is further treated with Rx, you get a secondary amine. So see, when RNH2 reacts with Rx, you get secondary. When secondary amine acts on Rx, you get a tertiary amine. So those are the 3 reactions given there. With ammonia, primary amine. With primary amine, go and see what it forms. It forms a secondary amine. When secondary amine is treated with Rx, it will go and form the tertiary amine. Is that clear?
Yes, ma'am.
Okay. Okay. The next 4 reagents are very, very important. Very, very important. Why? Let us consider this. And this is the most common give reason question in this lesson. Okay. Rx is taken. Okay. Rx is taken. And you are going to react it with Rx is taken. And you are going to react it with KCN. Okay. Look at this. KCN. And on the other hand, AG, C triple bond N. What is actually here? The polarity is this way. The cyanide is still the same. So, your potassium being a large cation will make this compound ionic in nature. Okay, potassium being large. Larger the size of the cation, more the ionic character. Remember, children, Fajan's rule.
Yes, ma'am.
Okay, so this bond is ionic. That means the negative charge comes to the carbon. The attack on the alkyl halide is going by the carbon, replacing the halogen. That means you would be getting R bonded to C, triple bond N. Is it clear, children? Aprameya, is it clear?
Yes.
But the moment it is AgCN, this bond, the Ag is a small cation. Now, smaller the size of the cation, more the covalent character. That means this bond is not ionizing right now. So, there is no negative charge on the carbon. That means the nitrogen with the lone pair is going to be the attacker. So, R will bond to nitrogen, which in turn carries the carbon with it. The Ag cleaves open to form AgX. Here the byproduct was Kx. So, your cyanide Cn minus could act as a nucleophile through carbon or through the lone pair present on the nitrogen. If it acts through carbon, the product will become RCN. If it is acting through the nitrogen, it becomes NC. So the composition of the nucleophile is same, but where it attacks, through which of the atom it attacks is different. It has got two different attacking sites. Such nucleophiles are called as ambident nucleophile. Where the two Cn minus and Nc minus both have got the same composition, but they attack through different sites. In Cn minus, the attack is through carbon. In Nc minus, the attack is through nitrogen. So, same composition, but acting through different attacking sites. The Cn, the cyanide ion, is an ambident nucleophile. So, if you use KCN, attack is through carbon, you get RCN. If you use AgCN, the attack is through nitrogen and you get an isocyanide. Are we clear? Are we
Yes.
clear? Okay. The same observation is made when, see, AgON double bond O. Do you think this will be polarized? This will be breaking off, children? Ag is smaller in size. Is this bond ionic or covalent? Ag being a small cation,
Covalent, ma'am.
covalent. So the lone pair on nitrogen is free to attack.
Yes,
The
ma'am.
product will be Rn double bond O, O coordinate bonded. And the byproduct will be AgX. But if you react it with KNO2, KNO2, this is put together, it's said to be AgNO2, KNO2. Now we know that this is K plus and O minus N double bond O. So now since the potassium is larger cation, the negative charge is very much available on the oxygen. So the attack happens through oxygen and R connects to oxygen, then nitrogen double bond O, and this compound is said to be alkyl nitrite. These are said to be alkyl nitrites. Nitrite, Nitrite. Whereas here this is said to be nitroalkane. So again, NO2 minus can either act through nitrogen or can act through oxygen. So again, this is an ambident nucleophile. Is that clear?
Ma'am, can you go up a bit?
Yeah. Take a picture of that. If you are on mobile and moving. The basic idea is that potassium is a group 1 cation. It's quite large. But Ag is a transition element. By the time I move from potassium to silver in the transition element series, the size is quite small. Smaller sized cation makes the compound covalent in nature. So reaction number, this one, KCN, AgCN, KNO2, AgNO2 is over, right? These 4 are over. Can I proceed?
Yes.
Okay. The next one is Rx. See, this is wonderful reaction, but you will not find this reaction used much in your textbook also. Apart from this table, it's not mentioned much. The nucleophile is RCOO minus Ag plus. I told you that it is not very covalent. It's covalent. Ag is small cation, it is covalent. But the polarization does happen because of the fact that the negative charge is stable, resonance stabilized. So the bond is able to break off free. And because of that resonance, the O minus acts as a nucleophile, drives out your halide, and you will be getting R. This is R. Okay, or we will start writing from here. So it is R dash C double bond O, O, R. So you get an ester. This reaction, excepting for this table, you will not find anywhere else in the text. Okay. The next one is lithium aluminium hydride. Okay, Rx plus lithium aluminium hydride. It is an excellent reducing agent. A reducing agent is able to add hydrides. What does it provide? It provides hydride, H minus. Lithium aluminium hydride is the name. Or lithium tetrahydridoaluminate is the name. So this provides H minus. H minus goes and attacks. X minus comes out. You will be getting RH. Okay. And finally, the organometallic compound. This is R minus, metal plus. The last one, please understand, it is Rm. Say, for example, CH3Li. So lithium is positively charged. This is negatively charged. So what does it provide? This is the reagent. What does it provide? It will provide a CH3 minus. So treat it on an Rx. The CH3 minus attacks and you will be getting RCH3. So you get an alkane. Isn't it same as Grignard, children? Isn't it same as Grignard? RMGX, where the nucleophile is R minus?
Yes, ma'am.
Yes.
Okay. So these 4 are very, very, very important reactions in terms of give reason questions. These 3 you will see in the last lesson also. This is Finkelstein. This is second lesson's Williamson synthesis. This is this lesson's hydrolysis. Okay, all these are example of nucleophilic substitutions. All these are examples of nucleophilic substitution on alkyl halide. And remember, aryl halides will never undergo such substitutions easily. You cannot expect any one of them to NaOH, room temperature, nothing happens. But if you use 623 Kelvin and 300 atm pressure, then it is going to get replaced with O minus Na plus, and you treat it with H plus in the subsequent step, and this will become the phenol. So you needed extra efforts to do the nucleophilic substitution on an aromatic halide, but the nucleophilic substitution on aliphatic halide just like that happened without you using special conditions. Clear?
Yes.
Okay. Okay. Some of the conversions we will try to do so that you get an idea. Okay, there is a big list. There is a huge list. And I told you that Okay. I wanted you people to do some more questions. Remember? Will you sincerely do this lesson, children?
Yes,
No,
ma'am.
this lesson is
I
over in your school. I think
Yes.
for both
We wrote
Ishan
cycle test
and
on.
sorry.
I wrote a cycle test on that chapter.
Okay. So finish this lesson so that we can have a test in this week. Okay. By maybe,
Ma'am,
yeah, tell
I'm
me,
going out
Ishan.
of station, ma'am, tomorrow.
Okay. When will you return?
11th, ma'am. 11th evening, I think.
Oh
Not
my
sure,
God.
ma'am.
Okay. So shall I record and send it, Ishan?
Okay, ma'am.
Okay. So idea is you should take up tests, children. This it is not like 11th standard. You should write tests. Then only your marks will start improving. Okay. Aprameya, you also. You have completed
yes, ma'am.
solutions, electrochemistry, and kinetics in the school, right?
Yeah, and DNF.
You please tell me to frame question paper from those lessons also.
I understood only the first two lessons. The rest was
Okay,
very
okay.
kind of
Fine, sir. So whichever lesson now, please keep writing tests. That is the most important thing here. Okay. So I'll prepare a question paper from this lesson and keep it ready. Please tell me when to send it to you people.
yes.
Okay. But you should
Ma'am,
take
you
up.
can my school ends on May 5th. Ma'am, you can send it after May 5th, ma'am. I'll
Okay.
study and write.
Right.
My
Pranav
school
also will
gets over
write.
on May 5th.
Pranav, you have not written the first lesson test also, na?
Yes, ma'am. But my school ended yesterday, ma'am, so I can write it.
Okay. So you will write the first lesson also, solutions lesson also?
Yes, ma'am. Sure.
Okay. Right. Did I send you the question paper, Pranav?
Yes, ma'am. I think you did.
Yeah. Okay. So
Ma'am,
from
but
this
can I
lesson also.
resend it, ma'am? My WhatsApp got reset.
Okay, then I'll send it. Okay. So we'll go for some more time today. Prajesh is not there. Any problem in going ahead with 10 more minutes?
No, ma'am.
Okay. Aprameya?
No, ma'am.
Okay. Arrange the compound. Pranav? Any class after this?
No, ma'am, not yet.
Okay. Arrange the compounds of each set in order of okay. Why I was telling you this is please start working on these questions. If I take up each and every question in the class, it will take enormous amount of time. Okay. Okay. I don't mind doing it, but we have to proceed to next lessons also. And parallelly, if you work on the questions, you will get a better grip on those concepts. If you dedicate yourself to do the questions and come, it will become a faster process also for me to do it. Okay. Arrange the compounds of each set in order of reactivity towards SN2. So we remember SN2 given by less sterically hindered or primary more than secondary more than tertiary. Okay. So it should be either less sterically crowded or it should be primary, secondary, tertiary. So there are three compounds given: 2-bromo, 2-methyl butane, 2-bromo, 2-methyl butane. So every time start your structure writing from the last. So it is butane, 2-bromo, and 2-methyl. So this is the compound. That means this becomes a tertiary, children.
Yes, ma'am.
Okay. The next compound is pentane, 5 carbons, 1-bromopentane. So this is primary. The last one, it is 2-bromopentane, pentane, and on that bromine in the second position. So this is secondary. So very obvious, the primary will be more reactive than secondary than the tertiary. Okay, they are asking you to arrange it in the order. So they are not saying decreasing or increasing. So this one will be the most reactive, then comes this one, and then comes this. Okay, I'll give you the order in decreasing. Right. Okay, the next one is 1-bromo, 3-methyl butane. 1-bromo 3-methyl-butane. So it is butane, 1-bromo, and 1, 2, 3, 3-methyl. 1-bromo 3-methyl-butane. Oh, 1, 2, 3. So this is your compound. Okay, 1-bromo 3-methyl-butane. The second one is 2-bromo 2-methyl-butane. So again butane, and it is 2-bromo 2-methyl. So this is methyl and this is your bromo. The next compound is 2-bromo 3-methyl-butane. So butane, it's 2-bromo and 3-methyl. So now tell me, which is sterically most free? This is primary, isn't it, children? The first one.
Yes, ma'am.
This is secondary and this is tertiary. So in that order it will happen. Number 1, then comes, this is the second one to react and this will become the third one. Okay. The next one, 1-bromobutane. So it is butane, 1-bromobutane, propane, on which there is 1-bromo 2, 2 dimethyl. Then you have got 1-bromo 2-methyl-butane, 1-bromo and 2-methyl. Yeah, tell me. Now all of them are primary, isn't it? This is primary. This is also primary. This is also primary. Do you agree, children? Another compound is there. 1-bromo 3-methyl-butane. 1-bromo, 1, 2, 3, 3-methyl-butane. Yeah. All of them are primary. Correct? This is C subdivision. So which is sterically most free, children?
First one, ma'am.
First one. So this will be the first to react. Then after that,
Last one, ma'am.
last one. See, where the bromine is, the crowding is in much farther away places. Okay, it's much farther away. So this is 2.
Third one, ma'am, then.
Third one. And then this one will be 4th. Is it clear, Pranav and Aprameya?
Yes.
Okay.
Yes.
Pranav? Okay. Next question. I'm just picking some questions and doing quickly. 6.17 out of C6H5, CH2Cl, and C6H5, CHCl, C6H5. Which is more easily hydrolyzed by aqueous KOH? Tell me. One very,
First
very
one, ma'am.
important. First or second or?
First one.
Very, very, very important question this is.
Then second one, ma'am.
Why second one? Tell me.
Because it's very important, ma'am.
Okay. See, I told you benzylic carbocation and allylic carbocation. Remember?
Yes, ma'am. They're very stable.
They are very, very stable. These two are very, very stable. Also, tertiary carbocation is very stable. Okay, so here, if the halogen goes and see the question, they have not said SN1 or SN2. It's molecule's choice. Isn't it? It's not saying SN1 or SN2. So, if the Cl goes out in the initial stages, it will be leaving behind a benzylic carbocation. Okay, if the halogen goes out, this is also going to create a benzylic carbocation. But now this benzylic carbocation is supported by 2 benzene rings. Na?
Yes, ma'am.
So which is better? Having,
Second is better.
yeah. So carbocation, and supposing there was a question that this carbon having the halogen has got 3 phenyl rings, then that would be even better. Is it clear? If the halogen goes off, the phenyl rings will conjugate and will pour the electron density, making it stable. So the concept here is that it is benzylic carbocation. So since the benzylic carbocation is stabilized by two benzene rings, this will be faster to form the cation, thus faster to get the nucleophile. Is it clear? So the product will be CH, OH, C6H5. Okay. This also will form because it is after all the benzylic, but it will be slower than the other one. Clear, children?
Yes.
Yes, ma'am.
Okay. Then next one. Okay. And even if they had asked you, they wouldn't put a question. Why? Because what mechanism is this? SN1 or SN2? Automatically.
SN.
The moment
Yes,
there
ma'am.
is a possibility of a carbocation,
SN1, ma'am.
SN1. So even though it is primary, this first one was a primary, still it will go via SN1 because it is able to form a stable carbocation. Okay. So if there is a possibility of a stable carbocation, it will automatically go via SN1. Okay. So we'll go to the next one. The conversions we'll start doing quickly. Okay. The conversion is saying propene to propane 1-ol. 6.19. Parallelly, please start doing. Have I sent you exam idea for all three of you? No, I've not. Okay. Anyhow, there are. I'll send to all three of you. I've sent it to Aprameya. I think she was asking. Start doing the questions, and if you find like no, you need some support, go through the book. Otherwise, you do it yourself. Okay. So because I'm leaving some questions, so this I'm not doing. Okay. So please do. Okay, the first part, propene to propane 1-ol. Propene to propane 1-ol. Can we say simply hydration? But that hydration will follow the Markovnikov addition. Where
With
will
peroxide,
OH
ma'am.
go? No, I'm saying normal hydration. If you add water, you will get OH on the second position only, no?
Yes, ma'am.
But you want it on the first carbon. When
Yes,
we
ma'am.
go to second lesson, we have a special reaction called as hydroboration oxidation, where you can get selectively this alcohol. So hydration is not a good idea now. It's not a good idea now because if you do normal hydration, H2O in the presence of H plus, water will be added up, but OH negative part will go to that carbon which has got less hydrogen and positive part to that carbon which has got more hydrogen. So you will be getting the secondary alcohol, but I want a primary alcohol. So, but what I can do, I can set up an functional group on the first position. No? Can I not add Br here? And once I have the Br, let me replace it with aqueous NaOH. Are you getting the point, children? So what should I
Yes,
add
ma'am.
here? What
Ma'am,
should I add here?
HBr and your anti peroxide, ma'am. Peroxide.
Peroxide. Okay. Actually, in the next lesson, we will see something called as hydroboration oxidation, where you treat it with BH3 twice, then react it with NaOH and hydrogen peroxide subsequently, you get a primary alcohol. That's in the next lesson, preparation of alcohols. So after learning that, you can directly write that reaction here, nothing wrong. Both are equally correct. Both the reactions will be equally correct. Okay, so you get a secondary alcohol here, so normal hydration wouldn't help. Can I move to the next one?
Yes, ma'am.
Yes.
Second one, do you recollect this from your class 11? It is ethanol, CH3, CH2OH, but you want a butane, CH3, CH2, CH triple bond, sorry, C triple bond, CH. This is from class 11.
Is it preparation? I'm not sure. I don't know.
Preparation?
Does it come under preparation? Sir?
It comes under the acidic characteristics of CH triple bond CH. This comes under the acidic character. This is so acidic, then you react with metal. Okay, this is an sp carbon. When it reacts with sodium metal, you get C minus Na plus. Remember?
Yes.
Okay, you get a sodium ethanide. How will you use sodium ethanide? See, from the starting alcohol, you have two carbons. So this seems to be coming from alcohol. Can we not bring this in using a sodium ethanide?
Yes.
Okay, but next thing, is OH a good leaving group? Is OH minus a good leaving group?
No, ma'am.
No. Can you use acid? H plus
Yes, ma'am.
proton. But won't the H plus also be desired by the C minus?
Yes.
So idea is don't use H. Instead, you make it a good leaving group. So treat it with SOCl2 or any of the halogens by any of the reactions that you have. And now react it with sodium ethanide. Is that fine? Does it make sense? You will get this product, no? C minus present on CH triple bond C minus attacks. The Cl minus goes off as NaCl. And this segment gets added to the CH3CH2. Will you not get this product, children?
Yes, ma'am.
Yes, ma'am.
That's why this is coming from class 11. Similarly, I'll ask you one simple question. CH triple bond CH. I can treat it with any number of sodium I like. And I want this compound. Plan. What can be done? I can use any amount of this, any amount of this. How can I do this conversion? Can I not make C minus triple bond C minus Na plus Na plus?
Yes, ma'am.
Yes.
And treat it with CH3Br. C minus approaches, Br goes off. CH3Br. C minus approaches the methyl, Br minus goes. Won't you get this product, children?
Yes, ma'am.
2
Could you go
NaBr.
to the previous one for a second?
Okay.
Yes.
Yes, children. Can I proceed?
Yes,
724,
ma'am.
you
Yes.
don't mind? Okay, next question. 1 bromopropane to 2 bromopropane. 1 bromopropane. You need to bring the bromine here. What would you do? You first remove it. Now, so use alcoholic KOH and make it propene. Then go for normal HBr, correct? This is the most expected one. Like the most expected reaction or reverse also. Plan for the reverse. How would you plan for the reverse? If you have got 2 bromo and you want 1 bromo, what will you do? Wait, what man? Why you don't narrow? Idea is in front of you. First you remove that. So alcoholic KOH,
KOH.
propene. Then what?
HBr with
HBr
peroxide.
with antimer.
Peroxide. Okay.
Yes, ma'am.
Okay. The next one, toluene to benzyl alcohol. This is toluene to benzyl alcohol. Benzyl group, not phenyl, is this benzyl alcohol. Many people at the end will get confused when they see benzyl, benzene alcohol. So benzene alcohol, oh, this is phenol, na? They'll break down benzene, benzyl, benzene alcohol, and they'll put phenol for benzyl alcohol. Don't do that mistake, okay? So now think. There is no functional group. What can you do? Can you introduce a functional group or what?
Yes.
What can we do? Cl2 in the presence of Hne. If you did Cl2 in the presence of Fe dark or FeBr3, it will go to the benzene ring, which is of no use to me. But if you take Cl2 in the presence of HNu, you will get CH2Cl. See, I included a functional group. Now you can remove it and very easily because it is benzylic carbocation. Correct?
Yes, ma'am.
The next one, benzene to 4-bromonitrobenzene. Fifth part, benzene. This is like your class 11, 4-bromonitrobenzene. So which one will you do first, nitration or bromination?
Nitration, ma'am.
Nitration, nitro group is a meta-directing group.
Sorry, ma'am. Bromination, ma'am.
So first Br2 in the presence of FeBr3, introduce a bromine group. And because bromine is ortho-para-directing, the nitration, nitronium ion will be added to the para position. Remember all these children?
Yes, ma'am.
Okay. Shall I do one thing? I'll record these conversions rather than looking at it.
Yes.
Yeah. I'll record
Yes, ma'am.
these. Okay. Right. So we'll end the class with this and please start doing. Okay. On your own. Please start doing. Even though I have done, please start doing as though we don't know. Start from the nomenclature. I feel is these two nomenclatures you can, if you have very very long witty time, please you do. Otherwise, you start your questions from the third part. Okay, at least the second question is relevant. First question is it's very very time consuming. So remember, எப்போ free இருக்கீங்களோ that time you do. Start from 6.2. Do it on your own. I will send the exam idea. Please do compare your answers with the book. Okay.
Yes, ma'am.
Okay. Yes, ma'am. Okay then.
Thank you, ma'am.
Yeah. Bye bye.
Can you
Bye,
just,
children.
ma'am, 1 second, can you just show the amines? I'll just take a screenshot.
Which amines, ma?
The amine, the nucleophilic substitution.
Okay, it should be there. Ma. On the mail, I'll write it again for you instead of searching.
Okay, ma'am.
Where it must be.
Ma'am, can you write it and send?
Yeah. Okay. Yeah, I'll do it.
Okay, ma'am.
Okay.
Thank you, ma'am.
Yeah. Bye. Bye.
Thank you, ma'am.
Yes, ma'am.
formula and quadratic equations quadratic formula
Hmm.
so அது வந்து என்னக்கா வந்து ரூட்ஸ் கண்டுபிடிக்கிறதுக்கு ஒரு ஈக்குவேஷன் கொடுப்பாங்க.
ம்.
அதை ஏபிசி வச்சு அதாவது ஏஎக்ஸ் ஸ்கொயர் பிளஸ் பிஎக்ஸ் பிளஸ் சி அதே மாதிரி அதுல இருக்கிற இந்த கோஎஃபிஷியன்ட் ஆஃப் எக்ஸ் ஸ்கொயர் கோஎஃபிஷியன்ட் ஆஃப் எக்ஸ் அதுக்கப்புறம் கான்ஸ்டன்ட் டேர்ம் இருக்கும்ல
ம்.
அதான் ஏபிசின்னு சொல்லுவோம்.
ஆமா.
And that we use the quadratic formula to find
b square plus or minus
அது வந்து b minus b plus or minus b square minus 4ac whole root அதாவது minus b தள்ளி b square minus 4ac மேல by 2a இது வந்து ரூட்ஸ் கண்டுபிடிக்கிறது. டிஸ்கிரிமினன்ட் அப்படின்ற ஒன்று இருக்கு. b square minus 4ac அப்படின்ட்டு அது எதுக்குனாக்கா நேச்சர் ஆஃப் தி ரூட்ஸ் அதாவது if it is greater than 0 two distinct real roots. If it is equal to 0 two equal real roots. Less than 0 no real roots.
மிச்சு நீ நிறைய படிக்கிற நீ அப்ளை பண்ண ஆரம்பி மிச்சு நிறைய படிக்கிற வெரி
நான்
குட்
படிக்கிறாங்க ஸ்டெப் பை ஸ்டெப் நான் எக்ஸாம்பிள்ஸ்
எக்ஸாம்பிள் பாக்குற போடு
எக்ஸாம்பிள் பார்க்க போறேன்
வெரி குட்
with that formula only without looking into the example and just taking the answers after
Very good.
finishing it. I do like it.
மா மிச்சு ஐ திங்க் ஐ ஹேவ் டு டேக் யுவர் லேப்டாப் மா
Okay, give me.
திஸ் இஸ் வெரி ஸ்லோ
Give me. Give me.
யோ
Give me
இப்ப
that.
எதுக்கு வர நீ
ஓ சும்மா சரி கொடுத்தல போட மாட்டேன்.
இது சாப்பிடும் போது எப்படியா இது கிளாஸ் எடுக்கும் போது எப்படியா போறது
சும்மா வாயில வச்சுக்கோங்க அவன்.
இது அசித்ரால் வாங்கிட்டு வந்தீங்களா
நான் மட்டும் தானே போனேன். இங்க பக்கத்துல ஒரு லோக்கல் மருந்து கடை இருக்கு புதுசா ஒண்ணு.
இங்க இந்த பால் கடை பக்கத்துலயேவா
நான் அங்க வரைக்கும் போகல இங்கதான் இங்க சைக்கிளுக்கு காத்தடிப்போம்ல.
அதான்டா இந்த பால் கடை பக்கத்துல தானே மேலே ஏறினா மெடிக்கல் ஷாப்
ஆமா காம்ப்ளெக்ஸ் எவ்வளவு கடை போயிடுச்சு. ஒண்ணும் அது இது வாங்குறதுக்கு அவனுக்கு கேட்டேன்னா காசு பண்ணி கொடுப்பா அப்படின்ட்டு சரி இங்க இருக்கிறதுக்குள்ள சேஞ்ச் இருக்கும் அதை எடுத்துக்கோ அப்படின்ட்டு ட்ராயிங் பண்ணணும் அப்படின்ட்டு அதனால எது எடுத்துக்கணும்னு சொன்னேன். My intention was not to stage my. So, you are my son. So, to deny it, I'm not your son. You don't can't understand the bush. நீ கற்பனை நான் முடிச்சுக்கானே இல்லையா அப்படி படிச்சோமா வேண்டிட்டா நீ வாய் மூடி ஒரு நாள் சரி ஓகே நான் வச்சுக்கிறேன் நான் வேலை பண்ணியா அதான் அடுத்தது சொல்றேன் நானு அம்மா டீச்சர்ஸ் எழுதுறோம் மற்றபடி யாருமே எழுதுறாங்க தப்புனாக்க நாங்கள் சொல்றோமா இல்லையா இது புரியுது இந்த தப்பு பண்றோம் இது எனக்கு தூக்கம் வந்து நம்ம பண்ணிட்டாவே இல்லையா சும்மா படு சும்மா நைட்டு சொல்ல வராது அவ்வளோ அக்கறை வந்து அம்மா கிட்ட also when you look at it, the bottom of the which is the same. No, not that much bad enough. You better look at it trying to. So I don't like it. Right now, ம்